Hi, this is Bono. Today I'd like to talk about conductors and insulators and resistors. Last time we looked at the electric circuit, a loop, and the schematic that represents it with symbols. Today we go one step further into the materials and parts that the circuit is made of. What's the difference between things that conduct electricity well and things that don't? And the resistor, a part used all the time in circuits. What is it actually for? Once this clicks, how circuits work gets much more familiar. By the time this video ends, you'll be able to explain, in your own words, what's the difference between a conductor and an insulator, and what a resistor does in a circuit. There's no hard math in today's topic. It's fine even if you haven't seen the last video, so please watch to the end. First, let's start with the difference between what conducts electricity and what doesn't. Look around you and there are things that conduct electricity well and things that barely conduct it. Metals like copper, aluminum, and iron conduct electricity well. A substance that conducts electricity well like this is called a conductor. On the other hand, rubber, glass, and plastic barely conduct electricity. A substance that doesn't conduct electricity like this is called an insulator. So where does this difference come from? The key is the number of electrons that can move freely inside the material. Free electrons. Picture people who can run around an open square. Inside a metal there are many of these free-moving electrons. So a crowd can run all over the square and electricity passes along easily. That's a conductor. In rubber, by contrast, the electrons are held tightly by the atoms, packed so tight they can't move. So electricity doesn't pass. That's an insulator. Compare how hard it is for electricity to flow in a conductor versus an insulator, and the difference is enormous, said to be more than 20 orders of magnitude. It's not a little different, it's a whole different world. A familiar example is a power cord. The copper wire running through the middle is the conductor. The rubber or vinyl sheath wrapping it is the insulator. Electricity travels only inside the copper wire, and the surrounding sheath keeps it from leaking out. Conductor and insulator divide the roles within a single cord. Here's just one name I want to give you a heads up about. So far we've talked about the two extremes, a conductor that conducts well and an insulator that barely conducts. In fact, there are also materials with conductivity roughly in between. That's the semiconductor. The brains of smartphones and computers are made from these semiconductors. Why semiconductors are so important and what they really are. We'll cover all of that thoroughly later in the series in the electronics chapter. For today, just tuck away the name. Between a conductor and an insulator, there's an in-between material called a semiconductor. Next, let's pin down the word resistance. Resistance, in a word, is how hard it is for electricity to flow. The harder it is to flow, the bigger the resistance. The easier it is to flow, the smaller the resistance. That's the relationship. Picture a hose carrying water. A thick hose lets lots of water flow, but a thin hose makes the water hard to flow, right? That hardness to flow is what resistance corresponds to in electricity. One note here. A moment ago I said metals are conductors that conduct electricity well. But conducts well doesn't mean the hardness to flow is exactly zero. Even metals have a tiny bit of resistance. There's nothing that flows perfectly and nothing that doesn't flow at all. It's more accurate to think of every substance as lined up by how hard it is to flow, the size of its resistance. Next, finally, today's star, the resistor. A resistor is the hardness to flow we just talked about, deliberately turned into a single part. Its job is to limit or adjust the amount of electricity flowing in a circuit, that is, the amount of current, to just the right size. Think of a water faucet. Just as turning the faucet adjusts how much water flows, a resistor adjusts the amount of current so too much doesn't flow. Why is such a part needed? An easy example is the LED, a tiny light. An LED itself has almost no power to get in the way of electricity. That is almost no resistance. So if you connect an LED straight to a source, electricity floods through it and it burns out in an instant. So we put a resistor in front of the LED. The resistor holds down the amount of current, so only a safe amount of current flows through the LED and it lights up properly without breaking. Like this, the resistor works all over a circuit as the part that watches over the current, so it doesn't flow too much. Here's a field note for you. Look at a real resistor and it's so small there's no room to print the resistance value as numbers on its surface. So someone came up with a way to show the value with colored bands. It's called the color code, and it's set as a worldwide standard. For example, in the common 4-band type, the first 2 bands are the digits themselves, the third is how many zeros to add, and the fourth shows the size of the tolerance. The colors and numbers are fixed too. Black is 0, brown is 1, red is 2, and so on. Once you get used to it, just seeing a sequence like brown, black, red, gold lets you read off, that's 1000 ohms, 5% tolerance. In other words, the color code is like a field cipher. Without flipping the part over or measuring it with a machine, you can tell the value just by looking at the colors. You'll always run into it once you start tinkering with electronics, so remembering that the colors on a resistor mean something is sure to come in handy. Now, a quick check to test how well it landed. This time too, 3 questions you'll trip on unless you really get it. Take a moment to think. Question 1. Why does a metal conduct electricity well? 1. Because it's hard. 2. Because it has many electrons that can move freely inside. 3. Because it's a metal. Question 2. An insulator like rubber conducts no electricity at all. The flow is exactly 0. Is that true or false? Question 3. Let's read the resistor on screen with the color chart from earlier. The bands are red, violet, orange, gold. So what's the value of this resistor? All the choices are split 5% tolerance. 1 27 kiloohms, 2 22 kiloohms, 3 47 kiloohms, 4 2.7 kiloohms. Have you settled on your answers? Let's check them on the next page. Alright, let's check the answers. Question 1's answer is 2, because it has many electrons that can move freely inside. Whether something conducts isn't decided by hardness or by being a metal, it's decided by how many free-moving electrons there are. Question 2's answer is false. An insulator isn't perfectly 0 either. It's just astronomically hard to conduct. A tiny bit does flow. Question 3's answer is 1 27 kiloohms. Red for 2, violet for 7, together 27. Then the third band, orange, adds 3 zeros, that is times 1000. So 27 times 1000 is 27,000 ohms, or 27 kiloohms. The tolerance is gold, so plus or minus 5%. By the way, misreading one color gives you a different answer. Choice 2, 22 kiloohms, is if you misread violet as red. Choice 3, 47 kiloohms, is if you misread the first red as yellow. Reading each single color accurately is the key. How many did you get? Go back over any you missed. So today we've talked about conductors and insulators and resistors. First, whether electricity conducts or not is decided by the number of electrons that can move freely inside, free electrons. A metal with many free electrons is a conductor that conducts well. Rubber and glass with few are insulators that barely conduct, and their hardness to flow differed by orders of magnitude. That's exactly why, like a power cord, copper wire can carry the electricity while the sheath keeps it from leaking, a division of roles. And that hardness to flow itself was resistance. So when you put a resistor, hardness to flow turned into a part, into a circuit, you can limit or adjust the amount of current however you like. That's exactly why even a zero resistance LED can be lit without breaking, just by adding one resistor. Looking at it this way, today's story connects into one thread. How well electricity conducts is decided by the number of free electrons, and a resistor is that hardness to flow turned into a part. Keep in a corner of your mind the sense that it runs continuously. from a material's properties to a pot's function. That's all for today. Thanks for watching.